Now that you've become acquainted with those algorithms, you need to know how to use them. Now, I'm not gonna lie, I knew most of those algorithms before I learned them from the method. And so trying to memorize UF to RU to LU just didn't seem to work well because the OLL formation of it was too prominent in my head for me to ignore it. So I devised this thought process in my head, and it won't work unless you're doing it blindfolded. I figured out after a long time of trying that the only way you can understand this method is if you're actually wearing a blindfold. So what you need to do is get your memo down. For me, this would be, what would it be? M-E. So me. And you close your eyes, and you look in your head, and you see that for this to go to M, whatever this is going to need a flip. And then for M to go all the way around to E, it's not going to need to flip. And so based off of that image in my head, I know that this is going to flip, this is not going to flip, and it's going to go clockwise, or this is going to go here and this is going to go here. And so I do the algorithm. And there's always one algorithm that works for that. And so you do the same for the corners. Although for corners it's always a little bit harder. For example, you would my memo for this would be I M. So you'd close your eyes and you'd look in your head and you know that it goes like this, to I to M. Now for corners, I have learned a lot of little tricks. Like, if you're going to permute here, then if you're going to permute from here to here, it's going to be, your OLL is going to be facing that way. And the same for here. If it's going to go from here to here, your OLL is going to be facing this way. And just the opposite for right here. If it's going from here to here, your OLL is going to be here. And if it's going from here to here, your OLL is going to be here. So since this is going here, I know that this piece has to be facing this direction. Now to go from I to M, you're going to need to flip the piece. So it can't be up. However, since you're not going to flip this piece up, then it can't be this direction. So since it can't be here or here, it has to be here. And so if you know that this faces this way and this faces this way, then this has to face this way. And since you know it's going in a counterclockwise cycle, the only thing you can do is R2 F prime, R2 F prime, L, F, R2 F prime, L, prime, F2, R2. The thing about TuRBo is that it's going to take you a long time to get this method. I can't absolutely teach you the best way to do it because you have to figure this method out for yourself. Now, for parity, if I have parity, I always like to try to just leave it so it's on the top. Now, the best way I know to put the parity PLL on the top, okay, so let's say you have a parity case at the end, where one piece is in the top layer and one piece isn't. The way I would handle this is I would permute my buffer position to the piece that's in the top layer and permute that to the piece that's not in the top layer. And so the piece that was knocked out of the way to move up this piece is going to be permuted correctly. And so the only two pieces that are left out of position are these two. Now let's say I'm in a position where both pieces are not in the top layer. Then I would do a setup move where one is moved into the top layer, and to move my buffer position into this one. Undo setup move. Then I would do what any logical memo scheme would do. Move this to here, move this to here. So there we go. And then we are left in a position where we have a piece in the top layer and a piece not in the top layer. And this is a special case as well, since the buffer position is one of the two pieces left over. You can just permute this piece into where it needs to go, and you'll be left with these two pieces swapped. Another way you could have handled this particular case is to do RL prime and then do an H perm. And then you have these two pieces in the top layer. And I suppose if you wanted to get really good at TuRBo, you could memorize all of the ELL algorithms and be able to do stuff like that and be amazing with it. But I don't know, do it if you want to. And you should be able to do the same for corners, but as usual, just with more effort. And then at the end, you have to always visualize the PLL case and do it. And that's it. That's TuRBo. I'm sorry for this rather abrupt tutorial that leaves you looking for explanation, but TuRBo is just something that you have to work at, and nobody can teach it to you all the way. You have to learn some of it by yourself.